Hello, everyone. So, we have been off to a great start here this semester in game hacking. Everything seems to be going swimmingly. I have had no one report to me any incidents or events, at least outside of the very first day, where some people were a little early. Not that that's a bad thing. It's fine. But those are the only complaints that I've had, so I assume everything's going just great for everybody. Now, we've been in the game a little bit. I had a chance to walk around and get the lay of the land a little bit. But we have an issue. And that issue is that we walk very slowly, and I don't like that. Now, there's a couple of ways that we can manipulate that part of the code in the game. We could do what is known as a trainer. A game trainer is essentially a separate application that we will run. It's basically a debugger that attaches to the main game process, the client resident process when we execute the game. As a debugger, it has access to the areas of memory that are associated with that resident process. The trainer, we program it essentially to find the pointer path to the variables we're looking for and change it, either with a switch or putting in our own variable. I'm thinking about doing something like that this semester. I didn't do it the previous times I taught this class because, honestly, it's kind of overkill for this game, but I'm thinking about doing it. But there's another way that we can do this, and that is with what is known as a bin patch or a patch. Essentially, we can take a look at the game files, reverse engineer the client, and instead of waiting until those variables are loaded into primary memory and then manipulating them with a debugger, we essentially change them in code. Now, such a thing is not always possible. Some variables are not static. Like, for example, your player position in the world. There's going to be variables that are declared in the code, but of course, they're not going to be static or you wouldn't be able to move around in the world. They have to be variable in order to keep track of your player's current position in the game. But some variables will be static, right? Like a variable for your in-game currency, that's not going to be static, right? Because they have no idea how much money you have, and plus you're going to be gaining and losing money as you play the game. So that's not going to be a static variable. But certain things might be a static variable. Like, for example, the amount of damage a single bullet does, the speed of a car or the speed of your player. Those may be static variables. And by static variables, I don't necessarily mean they don't change, because of course you have a player current speed, and this just for the sake of argument, I don't know what the code says, but you're going to have a current speed because the game needs to know if you're currently moving. So your current speed when you're holding still is going to be 0. But when you press the W key to move forward, it needs to detect that the button has been pressed, and then you need to accelerate to a certain speed. It needs to check if you're at that maximum speed, and then it needs to set that variable to a constant. There's going to be a limit, a speed limit, if you will. So, for example, with our walking in Pwn Adventure 3, what we might have, and what we're going to be looking for here, is essentially some kind of multiplier that says that when you are holding still, you're at 0, but when you press the W key, your speed will increase by X amount over Y seconds until you reach Z speed, at which point Z becomes your speed. That's what we're hoping to see somewhere in here. And if that's a static variable and it's hard-coded and we can locate that within the code, we can write a patch to change whatever X, Y, or Z happens to be to our own value, our own variable. What changing X would do in this case, maybe I should write this out. Yeah. Just a sec. Let me do an illustration here for you. Now, believe it or not, I have made many investments over the years in terms of my ability to teach remotely. I have, on my own dime, purchased for myself over the years, various different pointer devices and presentation devices and document cameras and even drawing tablets, for example, for situations exactly like this. And yet, when time comes to use them, too damn lazy. So we're going to use Paint here quick. All right, so what I'm getting at here is we have a game world, and within our game world, we have a player model, whether that model is visible or invisible, whether that model is whatever X, Y, and Z measurements it happens to be. It doesn't matter. It exists somewhere in the world, and we have the ability to control it. There's code somewhere within the game that waits for inputs, and when certain inputs are detected, certain events occur. So, for example, we have movement in our 3D environment with the WASD keys, the WASD, and relative to our player's current position, right? Assuming that we are facing in this direction, W would have us go straight ahead, the direction we're looking. A would have us strafe to the left, S would have us strafe to the right, and D would have us move backwards relative to our current position, right? So somewhere there's code that detects if those keys are pressed. So there's going to be also some kind of logic that runs when a key is pressed, in this case, when W. So a list of things needs to happen. It's not going to be immediate, right? So there's a variable somewhere. We'll call it speed. And when we're at rest, doing nothing, we're pressing no keys, speed by default is going to be 0. We're not moving at all in any direction. We're just holding still. When we press W, then speed needs to increase, right, in the direction we're pressing. So speed needs to increase in this direction. Now, later on when we get to teleporting in the game, we're going to learn that this is a little bit more complicated than that. But let's just say, just for these first videos, for the sake of introduction, in order to have a 3D environment, there's going to be 3 vectors at least that we need to look out for. There's going to be our X vector, our Y vector, and our Z vector. Relative to our current position, if this is a top-down view, I'm going to just kind of throw this out there. X, let's say we're oriented in this direction, is along this axis. Y is along this axis, and Z is up and down. So our height in the game. What we need to do is when we press W, we need to move forward, and that's forward to our current relative position, in the direction that we are looking. It may not be exactly X. It may be like maybe we're kind of facing in this direction or something along those lines, no matter where we're looking. So speed is going to be how fast we're moving, right? And then we're going to have direction, which is going to be 2 at least variables, probably 3 and perhaps more, as we will see later on. But we need to move at a certain speed in a certain direction, right, along X and Y. Now, most of the time, we don't need to keep exact. We don't need to keep our exact position in the code, right? We just need, everything is based off of the relative position. So, for example, when we press W, we might have an if check for if speed is 0, but it's probably going to be something like more like a maximum, right? Because there's going to be a certain maximum that we're going to be allowed to travel to, a certain max speed that is possible. We'll call that max speed, another variable here. And we're going to say that max speed is going to be, we could use a static here. We could say maybe an arbitrary number like 30. 30 is our max speed. So let's assume that. We'll even go ahead and use the number 30. It doesn't matter if it's 30 or 5 or 4. It's a completely arbitrary number because the speed is relative also to our current speed. But this max speed variable represents the fastest our character can possibly move. Now we're also going to have, I'm just going to abbreviate speed in this case. I'm going to do speed multi is going to be another variable somewhere in there, because we need to take our current speed and figure out how fast we get to 30. If you're playing a game and there is no multiplier, the speed goes from 0 to the maximum with a single key press, it doesn't feel very good. It's very jarring. You just kind of start moving at light speed, or your fastest possible speed. So generally, there's going to be a speed multiplier, right? A quick, barely perceptible, but certainly noticeable ramp up to maximum speed. Speed multiplier is going to be the amount by which your speed increases the longer you hold the key to move in that direction until you reach max speed. So our speed multiplier, let's say, is going to be, I don't know, let's say 1.5. So every time the loop cycles through, our speed equals our speed plus half of our current speed until we reach max. So now we can see that when we hit W, there's going to be a couple of things that happen. First, we're going to say there's probably going to be an if statement. So if speed is not equal to 30, then we're going to do some other things, like speed equals speed times, I'm just going to put multi. I should not have had it so long. It's really hard to do this in Paint. Something like that, right? We're also going to, of course, we can't do speed times multi if speed is 0. So we'll probably have another check in there like, well, let me scratch this out and just do like an or not equal to 0. And then we'll have another statement here if speed, okay, this is getting kind of crazy, equals 0, then speed equals 1, just to get us started. Some kind of code like that. All right. Now, all of these are static variables. The max speed, the speed multiplier, the initial speed value even, are going to be static variables. And if we can find them in the code, we can change them. Now, we don't want to change speed, because if we change speed and we say, guess what, speed now equals 1, well, then we're always moving. And we don't want to always be moving in the game. But if we can find the max speed, let's say that we can change that to 300, well, now we're moving 10 times faster than the current maximum. If we change the speed multiplier, then we are moving, we're accelerating much faster than we were before, right? In this case, maybe half a time is half as much as we currently are, or a third. In any event, we can make those changes. Now, we also saw in the game before that we have two speeds, right? We've got the speed that's the default speed, which is our running speed, but then we also have a shift plus WASD movement speed. And I don't know exactly what it is, but that speed multiplier, that max speed, there's going to be a statement when shift W, there's going to be some code on the back end, then max speed might be, I don't know, what did it seem like to you guys? It seemed like about a third as fast. Something like that. Now, ideally, what I would like to do is I would like to find this code, because that will give me two speeds. It will give me the standard default run speed, and then a much faster speed, because I want to change this to maybe 300. I don't know. We'll see when we get in there what it looks like. And then what that will do, because the problem with moving super fast is that you can move super fast and it's great, but it's more difficult to control the character. So if I have the default speed available, then when I don't want to move fast, I just don't press shift, and when I do want to move fast, I do press shift. So that's what I'm hoping to find somewhere in here with the bin patch. I just want to patch this variable, if I can find it, to another value. Now that's easier that's easier said than done. Okay, this is not going to be as simple as, oh, look, we're looking for the word shift. We're looking for the number 10. This is a conceptualization of a slightly more difficult task. In order to do this, we need to read that code, though. And of course, there's a problem with that. Code. Hold on a sec. So what we have here in front of us is code. This is C. As a matter of fact, this is source code for some of the future assignments in application security, right? This is how we know code as people, right? Knowing how to program means that you're familiar with the syntax and rules of a pseudo-language, a language that uses recognizable English words and such, but has different syntax and grammar rules. That is a bridge between a human readable language and a language that, or a set of instructions rather, that computers can understand. It's sort of an intermediary language between English and machine code. And when we finish writing an application, of course, we compile it. And when we compile information, we're basically converting it from that pseudo-language into machine code, right? Because the computer itself doesn't know what these instructions mean. It needs to be converted. There's another intermediary language known as assembly, which is essentially code that is broken down into individual instructions, CPU instructions. And it's as close as we can get, really, to reading machine code itself, down to raw byte level. And so the problem that we have is when we compile that code, what you see here, the original programming, the original code is lost, right? It's all converted. Now, there are programs out there that can help us, and they are known as decompilers. And what we're going to be using this semester is a decompiler called Ghidra, which I have here. You'll be able to find the Ghidra. It's available over on the public internet, and it is free. There's a GitHub. There's a site here, Ghidra-SRE. The button goes to GitHub. It'll take you to their newest version. Download this archive. Extract this archive. You will also need Java, JDK, I can't remember what version, 17? I'm not sure. Just follow the instructions and get this installed. If you get a Java error, it probably means you don't have the JDK installed. I think it's the JDK, not the JRE. Not the JRE. If you have Java, if you have the runtime environment, that's all well and good, but you actually need the development kit, the JDK. For Ghidra, if I remember correctly. And then when you extract that, there will be a batch file, of all things, in the root of that directory. Ghidra run.bat, which just runs Ghidra. And when it opens, if all goes well and you have all of your dependencies, you'll see something a little bit like this, except, of course, I already have an active project. What you're going to need to do is start a new project, non-shared project, and I'm going to name this project CIS 347. And then you'll see something like this. Okay? Now, the patch that we need to perform is going to be in the client, the game client. We can't patch anything on the server, obviously, because we don't have access to that. So such a thing wouldn't be possible. But we do have the game client, and since it's on our own machine, we essentially have complete control over it if we are so inclined. And in the game directory, there's going to be a couple of binaries. And you may want to initially try to decompile the binary here for the client, the one that you actually start to start the game. But look at the file size. 435 kilobytes. That's not going to hold all of the game logic. It's not possible. Feel free to decompile it, but there's probably nothing of value there. So what we're looking for, let me actually bring this back over here so you can follow along. If we go to Pwn Adventure 3, we go to binaries, Win32, we can see that there's DLLs in here. lib EAY32, SSL EAY32, and gamelogic.dll, which is another 643 kilobytes. Well, this is the part of the code that contains the game logic. So that's what we're actually looking for. That's what we want to decompile. A DLL is basically just code that has been compiled. It just doesn't contain a main function. A DLL is a dynamic link library. It's a bunch of code that has been compiled and is meant to be used with another program, but is essentially loaded after the program starts, and more code needs to be called. It's just a way of not having to package all of the useful code up into one place, but it's also a way of sharing essentially universally useful code, like the lib EAY32 and SSL EAY32. These likely contain functions that are useful in a general sense, and there's no reason programmers need to reinvent the wheel every time. They're not all writing their own, for example, they're not all writing their own I/O functions. They're not all writing their own mathematical functions and so on, right? No, you would import, just as we see here, where this code includes standard I/O. All right, I need to do that include because I am taking user input and I am printing out to the console. I'm not going to write my own code to do that. I'm just going to use existing standard functions, but since I didn't write them, they have to be packaged up. They're in standard I/O. And so on, right? Here's the signal include because I'm using sig alarm here for the sig handler, right? So that's what a DLL is essentially. In this case, it's just code that's being reused. The game logic DLL is not being reused, right? That's going to be what the game is about, right? That's all the things that are written for this specific game. So these ones we could decompile, but we're not going to get anything useful out of them. This is what we're really looking for. So in order to decompile that, I'm going to open up Ghidra here and put that back up on the front, and I'm just going to drag in. I'm going to drop, and I'm going to let that go. A portable executable file. Yes, this is the Windows binary. The language, it's taken a guess at x86. Yes, that is correct. 32-bit, sure. And program name. So we can check out options if you want to. So I guess everything looks fine. We're just going to hit OK, and we're going to allow Ghidra to do its thing. And what I'm also going to do is I'm going to C and V on our game logic DLL, because anytime you're going to be doing any adjustments or poking around or changing any code or doing any patches, you want to preserve your original. You always want to preserve your original in case you screw something up and you need to go back to it. So I'm just going to leave that game logic -copy just right there if I need to go back to it, and I can always roll back to that. There have been no changes so far, so everything is fine. All right, Ghidra is done with the initial intake. We have our compiler here. This was written in Visual Studio, and it's looking for a PDB file. Any of you programmers out there certainly know what a PDB file is, but if you don't, that is essentially a PDB is program database file. It's also known as a symbols file or a symbol file. Basically, as I mentioned before, when you compile source code into a useful binary, it's going to be converted into machine code. And there's one thing that machines don't care about is variable names. Variable names are a human construct that allows us to understand the process of programming, right? It's just an intermediary declaration, right? So that we understand what the purpose of a specific area of memory is within the context of our code. So since there's no need to have it in the compiled final product, it's generally not there, which means that if you're decompiling a program, you can get the instructions and a decompiler can take its best guess at the original source code, but it's absolutely not going to have any way of knowing what the variables are, so they won't be there. That's all contained in a PDB file, and it's usually part of the compilation process because that way, if the programmers for whatever reason need to go back into the compiled code, they can use the PDB file to follow the logic, because the compiler may change things, right? the compiler doesn't just convert it to machine code, it also wants to make it as efficient as possible, so it's going to move some stuff around, it might declare variables slightly differently, it wants everything aligned on certain offsets, and so on and so forth. So if a change is made and for some reason it's not working after compilation with the PDB file, you can open that back up, decompile it, and then the PDB file can help you to understand where things ended up after compilation. So normally the PDB file will only be held by the developers someplace safe, and it will not ship with the final product because there's no need for it to. In this case, we do have a PDB file, and it was accidentally shipped with the game. I say accidentally, but it wasn't accidental. Also, look at the size of it. Like, look at this PDB file with the source code and variables, and look at how much information is saved in the compilation process. A tremendous amount. So it managed to find the PDB file. If it hadn't found it, then in Ghidra I would have pointed it to it anyway, so we will go with it. So game logic there is now in our list, and it's ready to go. So if we double click that, we get the dragon icon coming flying at us. And Ghidra opens up. The first thing it wants us to know is if it wants us to analyze this. So Ghidra has done the decompilation. In the background we can see here's the assembly code, but notice that we don't really have any source code here. And we're not going to get the exact source code back. What we are going to get is an approximation of the source code according to the instructions that are in the compiled code in the estimation of Ghidra's intake scripts. And that's a process called analyzing. And that's what it wants to do right now. It wants to know if we want to analyze that code. So let's say yes, sure, for now. And then we're going to make sure that we have the correct options here selected. Ghidra has some prototype options here by default. I think most things are going to be checked. PDB Universal, Platform Independent PDB Analyzer. Okay. Or we have PDB MSDIA. Do I have the MSDIA SDK on this machine? I don't think that I do. Let me see. Well, I do have Visual Studio on this machine, so I assume that I do have the DIA is the Debug Interface Access SDK Software Development Kit, MS Microsoft. It's something that is used for reading PDB files, usually from Visual Studio, and we know that this was compiled with Visual Studio. So I'm going to go ahead and check that, and we'll see what happens. I might end up having to rerun with PDB Universal instead. If you don't have Visual Studio, or you don't have the MS DIA SDK, you can get it. Or just do, maybe I should do the PDB Universal just in case you guys don't have that. And let it do its thing. I'll get back with you when it's done. And it is done. So we have some PDB warnings here this time. Don't know. Let's get into it and find out, I guess. All right, so this is Ghidra. Ghidra is a decompiler that has been made available to us through the NSA, and you can use it in order to decompile code and take a look at it. There are many tools that will do this. If for some reason you're iffy about downloading something that's made available by the NSA, then there are lots of other decompilers out there. IDA is a favorite of mine. Radare if you're using Linux. There's lots of them out there. We use Ghidra because it is extremely free. It's also not bad. It's a very good tool. Over here on the, well, in the middle, I guess first, what we have here is the decompiled code. These are assembly instructions, right? Let me get to some actual code here where we can see the assembly instead of just null bytes. Here we go. Just kind of randomly scrolled down. So here we have assembly instructions. We have Zoring. Zoring is a assembly instruction for Zoring. In this case, the value in EAX with the value in EBP. We have move. So we're moving data from EAX to, oh wait, no, we're moving data from EBP to EAX. No, that's not right. It's supposed to be backwards. Okay, no, I was mistaken. the move statement here, typically speaking, there's different syntaxes for assembly. There's Intel and ATT, and the type matters. In Intel, which is, in my experience, the most common, typically the value that's being loaded is going to be the second position, and the first position is the location. And I was thrown off a little bit because that looked a little bit like a variable declaration, but I see now that it is loading the value in EAX into the address at EBP plus local 18. So this offset here of the base pointer, which whatever that value happens to be, local 18 references a local variable. So... but yeah, that's assembly instructions. As you can see, they're all basic instructions here that have been translated from basic binary machine code back into a somewhat human-readable fashion, except rather than being anywhere near the source code, it's a series of instructions as loaded in. And it is directly translatable to binary, right? So for example, if I were to take... the hexadecimal that we see here, 8945EC, we can convert that from hexadecimal back into binary. Just no problem. What you see here on the left-hand side, this is the memory offset. Because code these days tends to be position-independent executables, thanks to exploit protections like ASLR and so on, the home address where a resident process is loaded may be different every time that it runs. But we still need to know where code is. I should say the code still needs to know where the other code is. Like, for example, if I have a main function that calls a calc function or something like that, the main function needs to know where to go in memory to find the calc function. And so here, this function here is the bear attack for chest. This is the attack for chest function. And notice that it starts at this memory offset, so 69CO. So what this means is that wherever the home address happens to be, so the top address here in the program, if it needs to find attack for chest, if that's called for any reason, it knows that it can be found at the home address plus 69CO. And all code, all variables and so on, all declarations, all instructions are all going to be relative to that position. All right. Now this is difficult to read, but don't be dejected or anything. You do get used to it a little bit, and we're not going to be relying on it too much for this class. But you do need to know what you're looking at least, because if we're going to be working with it, well, you got to be able to see it. All right, then over here on the left-hand side, PE files are broken out by different sections: headers, text, RData, data, and so on and so forth. This is just a navigation pane. If you double-click these, it will take you to the beginning of those sections in the PE. Below that, we have our symbol tree, where we can see, well, number one, there are certain DLLs that will have to be loaded in order for a Windows binary to run. So for example, kernel 32 here, and these other ones, they're just basic DLLs that are required for Windows to run a PE. But we also see libeay32 and ssleay32, which we saw in the game directory. Those two are loaded here. They're in our imports. Don't worry about exports. Functions is basically any function that's found in the decompiled code. It will list them out here. If the PDB file contains a name, then it will name it that. So for example, there's an init items and quests. It sounds like a very interesting function that we'll have to take a look at later. But that's the name of that as given by the programmers. If it can't find the name of something, it will give it a temporary name. Ghidra will give it a temporary name. So in this case, we have some functions here that aren't labeled, and so they are given the name fun, and then an underscore, and then some letters and numbers, which are the memory offset where it can be found. So fun underscore 100 AFC4 can be found here at offset 1000 AFC4, along with all of these other ones. Now, one of the great things about Ghidra is that you can adjust things on the fly as necessary. So as you're figuring things out, you can change things. So if I just pick a random function here. All right, so this function here is unlabeled. Notice that when I clicked on these functions, the decompile screen changed because it's showing us essentially Ghidra's best guess at the original source code based on the assembly instructions, right? So it's figuring out this might be what it originally looked like. It's not at all what it originally looked like. It's just a facsimile thereof, but sometimes it can get pretty close. And so if we take a look at this function here, we see the decompiled code. We have some, actually, I don't really like this one. Let's do, all right, we'll go with this one, I guess. So let's take a look here and see if we can figure out what the code is doing, at least a little bit. We have here some variables being declared. We have a car, we have some ints, we have all kinds of code here. What's it doing? There's a while statement, while true. Go to whatever this label is. ivar4 is condition weight, and then it passes 2 parameters. Let's pick one of these then, and just kind of at random here, because it doesn't really matter. But let's say that we figure out that ivar1 here, this character, let's say it represents an important character. If I right click and rename the variable, then I can change that. Let's just put important car. I'm not sure exactly what it does, but it's fine. And it will change that, as it did here, but it will also change every reference to it, even here in the assembly instructions. So everywhere that it's referenced, it will be changed by name. And we can do that with functions too. Like if I rename the function, I can rename this to important function. And note that it gets moved out of the F category here into the separate important function here, or into an I category if we have enough of them, right? So that's just to kind of show you what Ghidra is a little bit about. Now, this is a DLL. Normally, when we're doing reverse engineering, we want to start at the beginning and work our way backwards. And for compiled binaries, executables, that means that we're looking for the main function, and then we work backwards. But this is a DLL, so there is no main function. If we look at functions here, there's just nothing. Because this is a DLL. There's no main function. This isn't meant to be executable. This is just other code. So we can go further down. We could look at labels. There might be something interesting in there. Like maybe we're looking for like a, well, there's no main label, of course, but maybe we're looking for like a player label. Is there one of those? Well, I don't see one. I don't see one at all. There's a user label, but that's for user 32. That's not what we're looking for. So we're probably not looking for a label then. So let's collapse that. Let's look at classes. All right. Is there a player class? Well, I see here's a just intolerable class. We know that just intolerable is our one of our NPCs. We know that from being in the game. We can see here's a get display name function, an initial state. Here's a just intolerable, and this is going to have all of the code that's associated with him, most likely. Who knows what the game might have. So here's his dialogue. The same bears are here too. But maybe if it's an NPC that can be killed, maybe it's got a flag for whether or not he can be killed, or he's an essential NPC. Maybe he's got a health pool or something. But all of that would be here. We also have a key verifier class. That sounds like it's going to be very interesting for one of our later assignments, but we'll put a pin in that. We have a quest class. Here's P. We do have a player class. We have a pistol class here as well. That player class has a whole bunch of interesting things that we're going to want to take a look at later. There's an add item thing. Maybe we want to give ourselves item. That might be a good place to start looking for that. Advanced quest to state. Well, heck, maybe we can just kind of breeze through the class by just skipping all of the quests and marking them as complete and giving ourselves the flag. Looks like we can maybe give ourselves invulnerability. There's a can be damaged call here. AI actor should target player. It's true. If we switch that to false, what does that mean for us? Maybe that's an immortality. We'll get to that later. Right now, I really want to focus on speed. Can jump, can reload, complete quest, yeah. Damage, is that the amount of damage we do? Actor, item, yeah, it looks like it could be. Could be. But again, that's not our speed, and I really want to focus in on that. Enter AI zone. I'm guessing that the enemies have an invisible bubble around them and a point at which they will chase you and attack you, and then if you leave the area, they'll stop chasing you. That's probably the AI zone. NPC shop. That might be Max Payne's shop. Enter region, equip item, exit AI zone, fast travel. That might be that might come in handy if we want to get through that. Free quest list, actor interface, avatar index. inputs, colors, probably the colors you pick when you create your character. Get current item, get current quest, get fast travel destinations. That will also be interesting for us. Item cooldowns could be interesting. Jump hold time. That's actually going to be really interesting. I might look at that one after we manage to update our speed. Jump hold time indicates if you hold the jump button, how long, if you hold it down, do you jump before you stop going up, gravity takes over, and you begin going down. Which means that if we can influence that, we can essentially fly or float. So we'll look at that second, because that would also be nice. Jump speed, get local player, look position, look rotation, get mana. That will be interesting, yeah, if we want infinite mana. Get quest list, spawn location, get state for quest, get team name, get walking speed. That's probably what we're looking for. We can see that get walking speed apparently just returns this M remote look position on the x-axis, whereas the jump hold time was essentially the same thing on the z-axis. So up and down versus forward and backward or left and right, depending on which way you're oriented. So that one might be a winner. Let's see what else we got, though. I'm just going to quick scan on killed, so what happens when we die. Perform buy item. That might be good if we want to... okay, there's what it's looking for, coin. That might be good if we want to give ourselves infinite money for shopping. Perform chat, perform respawn. I'm looking for maybe something that is... oh, here's perform submit DLC key. We want to take a close look at those later on. Here's our actual player function. This is going to contain all the information about our actor. Actor is game speak for the characters that are in the game. So it'll be their models and their logic. Current region, field, remote look position X. This is what is called by get walking speed. We can see that the value is set to some weird float here, some extremely specific float. And then we have the remote position Y and Z are set to 0, mana set to 0. This must be our initial spawn into the world. Yeah, Lost Cave, that's where you spawn in. That could be. Not sure. We'll have to take a closer look at that. I'm not seeing what I'm looking for there, so we're going to move on. We've got a sell item function. That might be interesting. Set PvP, set sprint state. So set sprint state is whether or not it detects if we're hitting shift, I guess. Game world code int game world hex 30. Does that mean that I was correct and that our walking speed is a third? Probably. Submit DLC key. Tick. A tick in GameSpeak is essentially one full loop of logic where things are processed every tick. So positions are updated every tick and so on and so forth. It's a very fast counting speed essentially for most games. Transition to NPC. Use mana. That might be good for infinite mana as well. This doesn't look quite right. I'm thinking that maybe Ghidra might be having a little bit of an issue here. I might have to troubleshoot this a little bit. Okay, I don't see anything else that had to deal with sprinting or speed, which is what I was looking for. But if we wanted to, we could search. So we can search through the program text. If we look for all blocks, listing display, all fields. If we search for sprint, We can see all the places where sprint appears, whether it be in a label or a comment or something. It's not going to find everything, but it might get you near the code. Like, for example, I missed this before. There's a get sprint multiplier in the player namespace. I didn't see that. We can see that it's return 3.0. So yes, a walk is officially a third, except it seems the walking speed is the default speed. And then when you don't press shift, it multiplies whatever the default speed is by 3. So it's not, I thought it might be the other way around, like the default speed was running and then hitting shift maybe multiplied it by 0.3 or something, but apparently that's not the case. So that means that if we find this value here, return 3, we can bin patch this and increase our speed, give ourselves a permanent speed boost. Instead of being 3, it would be whatever we set it at. I've done that in previous courses. If you want to see how to do that, go ahead to those playlists and follow that instruction. It's pretty easy. You just use HXD, you locate that code, you overwrite the value with whatever value you want, save the DLL, and you're good to go. But I actually want to do something different this semester. Rather than doing a static bin patch, I think I want to build out all of my cheats into my own trainer. And I think that's what I'm going to do. So I'm going to leave Ghidra up in case I need to go back and reference code. But what I actually want to do in the next part, because I'm going to stop this part and we'll move on to the next one, I actually want to pull up a debugger, and I actually want to get in the game and start manipulating it live rather than doing a static bin patch. So come back for the next one. It'll be when we actually start doing some stuff here.